Okay, so we are going to talk about some electron transitions. Now, oh shoot. Well, okay, so if we have our transition going from 6 to 3, our equation is change in energy equals final energy minus initial energy. So our final energy is the energy of energy level 3, and our initial energy is energy level 6. So we look on our energy level guide here. Energy level 3 is right there. So it's negative 146. Ooh, that's really bad. Negative 146 minus negative energy level 6, which is negative 36.4. And those are in kilojoules per mole. I'm not going to write them because I am limited in my space. But that turns out to be negative 109.6 kilojoules per mole. Okay? Now, from there, we can also find the wavelength and frequency. First, we're going to find frequency. So for that, we would do energy equals h, which is Planck's constant, times frequency. Okay, I talked about that in a previous video and how to do it, so I'm not going to go through that whole thing, but the frequency turns out to be 2.748 times 10 to the 14th hertz. Okay, and then we can find the wavelength with this equation. C equals frequency times wavelength. Again, I talked about how to do that in a previous equation, so I'm not going to go through that whole thing, but the wavelength turns out to be 1091.88. Okay, oh, and that's nanometers. Okay, now, next one, same thing. We take our energy of number 2, we take our energy of number 4, and we subtract them. So, negative 326 minus negative 82. And that turns out to be negative 244 kilojoules per mole. Okay, then we do the same thing. We use this equation to find frequency. We use this equation to find wavelength. And those are respectively 6.12 times 10 to the 14th hertz. And 490.45 nanometers. Okay. All right. Last one, but first I got to erase some stuff here. Okay, so our last one is 4 to 1. So 1 is our final, 4 is our initial. So final, negative 1312 minus negative 82. And we get negative 1230 kilojoules per mole. We plug that into this equation. We get 3.08 times 10 to the 15th hertz. And then we plug that into this equation, and we get 97.29 nanometers. And that's it.